What do you think happens when you drop that on a nuclear reactor?
So that's a really common anti-nuclear narrative that you get in society where people will say the reason why we shouldn't do nuclear energy is because it could become a military target or maybe terrorism or just by accident you're going to have a disaster. And the truth is the biggest accident that we've ever had is not Chernobyl. It was the Banqiao Dam. Chernobyl, it killed a few dozen people outright, caused a few thousand cancers. But the Banqiao Dam, when that went in China in the past century, that took out tens of thousands of people right away, and the after effects killed up to hundreds of thousands of people. There's a great reference for it right there, if you want to go and check that out. But let's look at the actual the math and the expectation. Some people think that if you dropped a massive bomb, say a nuclear bomb on a nuclear power plant, that would make the nuclear blast bigger. It can't. It doesn't. What ends up happening is that a nuclear bomb requires pure fissile metal. You don't have that in a nuclear reactor. The fissile material is spread out through the fuel and through the moderator and through the structural materials cladding, and the fuel itself is not going to be pure fissile metal. And so you can't have a prompt nuclear yield like that from a nuclear bomb on a nuclear power plant. What ends up happening is it makes a really big mess. So let's contextualize this a little bit. It's been known, there's a nice little reference, since the 1960s, and even it was published again in the 80s, but it wasn't really made popular until this century by Scientific American, where they pointed out, and there's the reference for Scientific American, where they pointed out that a coal plant can easily release more radioactivity per gigawatt hour than a nuclear plant creates. Now that sounds pretty crazy, right? Especially with this rhetoric out there about what happens if you drop a bomb on a nuclear power plant. It comes down to this. It comes down to energy density. Now, how does that make such a ridiculous thing happen that you get more radioactivity per gigawatt hour from coal than nuclear? Doesn't that sound insane? Well, let's look at the physics, shall we? Turns out when you're doing any kind of combustion of fossil fuels, you get about 1 electron volt per atom of all of the atoms that are taking place in that combustion process with the hydrogen and the oxygen and the organic material. It's about 1 electron volt per atom. When I fission uranium-235, I get 200 million electron volts per atom. So it's hundreds of millions of times energy density. Okay, so what? How does that have to do with anything? Natural radioactivity, just uranium alone. Uranium alone is 3 parts per million on average in any dirt. That doesn't include all its decay products, radium and its decay products, or thorium, or any of those other decay chain product, radioactive decay chain products from that. So if I just got 3 parts per million, just do the uranium, not the radium or any of their decay products, 3 parts per million in coal, but I only get 1 electron volt per atom, you can see how that makes it really easy for you to actually have a lot more radioactivity per gigawatt hour from coal than from nuclear. Yeah. And so if I dropped a big bomb on a coal plant, I'm going to kill a lot of people at the plant. Same would happen in a nuclear plant, say a nuclear bomb. But the radioactivity from coal doesn't scare people because it's natural. And what we know from science is that dose is dose. It doesn't matter if you get the dose from a medical source, an industrial source, or even from making electricity. Dose is dose. Effective dose, by definition, takes into account all sensitivities. And so effective dose is effective dose. So people tend to not be afraid of getting dose, say, from a plane ride or from natural radon in the air when you're up hiking in the mountains where all of the uranium in that granite gives you this fresh mountain air with extra radon in it. You don't really think about that, right? Because you figure, well, I guess, evolution means we're designed for the biosphere. That's not an issue. But if it's man-made, particularly from electricity, then it becomes scary. So that is a really common anti-nuclear narrative for people to ask, well, that's really scary to drop a bomb on a nuclear power plant. It's scary to drop a bomb where anybody is living. It's scary to drop a bomb on any energy source. It just so happens that the narratives around nuclear, just watch the Chernobyl miniseries where people get cooked and instead of the tissue getting cooked, it melts off their face. Hollywood does that. Anyway, I hope that helped. Let me know. Thanks for watching. Hope everybody learned something, enjoyed the video, and that you all have a great day.